Okay, thanks. Uh, Before I start, brief introduction of mine. I'm a founder and director of a company called Blue Infi Solutions and Security Exposure. In the past, I worked with NetSquare, Chase, IBM, and Foundstone. My primary interest is in web security. We at Blue Infi doing a lot of research and a lot of consulting work for different applications on application layer assessing and building a source code scanners and building application scanners. Here is some of the tools which we are going to cover during this presentation would be like WS Scanner, Scan Web 2.0, App Map, App Code Scan, App Print, etc. And these are some of my books: Web 2.0 Security, Defending Ajax and RIA, Hacking Web Services, and Web Hacking. Before I start, lately in last 1 year or 1.5 years, we are seeing a lot of applications migrated towards Web 2.0 using different components of Web 2.0. And some of the cases, this is like one of the recent assessment which we did with a Web 2.0 portal, where typical application for buying and selling goods over internet, typical e-commerce application. And if you look at the technologies, which is Dojo, Ajax, XML, services, blog, widgets, all these different components of Web 2.0 part of these applications. Now, what interesting about these applications are when you try to scan the product with a traditional methodology or a traditional tool, you are using any of the products or tool and try to scan those applications, the scanner will not work. Essentially, these applications are like a one-page application, either written in a Ajax or a Java script, the front end, and in the back end it's a web services. So there are no typical resources or typical hrefs you find in the application where you can traverse to the entire application and figure out the resources. And once you have the resources, you go ahead and do fuzzing or attacking those resources. So if we use the tools in products, try to scan the application, it's failed miserably. So no vulnerability found. No resources are captured, and pretty much like there are so many resources on these particular application, but none of them is discovered by this scanners. So we did manual testing as usual and started to discover a lot of different vulnerabilities in the application. All these application vulnerabilities are quite unique with a traditional way of your doing application or traditional way of scanning your application. And some of the vulnerabilities which we discovered is SQL injection over XML pipe or a JSON pipe, cross-site scripting, which is very common. You have a persistent, non-persistent cross-site scripting all over here. We found several routines of Ajax which were vulnerable. So we were discovered Ajax-driven cross-site scripting, several cross-site scripting with blog component. What they have done is they've integrated some open source blog into their application, and you were able to find so many cross-site scripting in the blog. Information leakage, one of the popular attack vector, and we were able to find a lot of information leakage coming out from the not traditional resources, but the Web 2.0 resources, which is running JSON services or such. And pretty much we were able to get into a system. We were able to do a remote query execution, owning the SQL database at the back end and all different stuff all over XML traffic or a JSON traffic. So this is a pretty eye-opening case when you start looking at the Web 2.0 application, and if you don't analyze it with a different perspective, then you end up missing a lot of different vulnerabilities in the application. So what we are going to cover in today is we start with the Web 2.0 new battlefield, where we are moving, some architecture, strategic changes which we are seeing, and what kind of enemies which we are looking at. And then we will quickly focus or browse through detecting vulnerabilities, like methodologies which you can follow to scan Web 2.0 application, to determine its fingerprints, discovery, enumeration, and crawling. And then we look at the top 10 attack vectors or issues. Now these are not the top 10 from OWASP or top 10 from some different organization. These are some of the top 10 which we have determined while scanning all these Web 2.0's products which we scanned, or Web 2.0 application which we scanned in last 1.5 years. So on top we have Ajax-driven cross-site scripting, then we have a JavaScript injection with the mashup applications, SQL injection of a 2-type, O-type, which we'll be going to see, CSRF with XML, CSRF with JSON or a JavaScript, RSS manipulation, reverse engineering and logical hacks, WSDL scan and exposure, SOAP injection and widgets and gadgets hacks. So these are the plan for today. How you secure your Web 2.0 application? So what you have is a Web 2.0 asset or a resource, which may be your JavaScript, or it may be running your web services, maybe on a client side or on a server side. What you do is you do two approaches. On a one, you do a footprinting and discovery, you do enumeration and crawling of the application, and then you do attack and scanning on each different application components and try to come out with the vulnerabilities. Or you put a white box approach methodology where you take the source code, analyze the entire source code, and try to come up with the vulnerabilities. By both the methods, or following one over another or both of them, you try to determine a list of vulnerability, and then you apply your secure coding or a Web 2.0 kind of a firewall where you are filtering your traffic for 2.0, and eventually you get your resource secured. So moving to a new battlefield, where are we moving? Architecture changes and enemies. If you look at like last 2 years, a lot of different applications, maybe a Gmail, Google, Dig, NetVibes, PageFlax, WordPress, Rightly. This is like a very small list of applications. There are tons of new applications coming out, or old application moving to a new heights. All these applications are using Web 2.0 extensively. So what we are looking at is adaptation of Web 2.0. Almost 80% of companies are investing in web services as part of the Web 2.0 initiative, McKinsey 2007 report, which just published in February. By end of 2007, 30% of large companies have some kind of a Web 2.0 initiative up and running. And 2008, web services or service-oriented architecture, which is popularly known as SOA, would surge ahead. So what we are seeing is there is a definite trend, or there is definite pattern which we are seeing where applications are moving towards Web 2.0, which has a two component. Definitely there is a drive for a social requirement and a better experience for application, and then there is a second drive is essentially where you are looking at consuming different applications from your APIs, and when you want to consume more than one application on your application, essentially what you need is you have to move towards a SOA or a service-oriented architecture. So this is a one trend which we are seeing, and that is where a lot of different applications which are coming for the assessment has this piece and components running. Now if you look at the change in the architecture of a Web 2.0 application, what you have over here is your web browser, which is using JavaScript or Flash-based components, and on the bottom it is written on HTML, JS or DOM. So this JavaScript are essentially running and gluing all different components of the browser. So you don't get a typical HTML page back on your browser, but you get a JavaScript coming to you, and then it is making a dynamic call at the back end. So that is your new kind of an old browser stack, but recoded differently. Then it will hit to your application server where various different web services are running, and you have your local database or authentication which is falling on your application infrastructure. Now what we are seeing is all different new applications coming up. They are publishing their web services through open APIs or APIs. So whether you are looking at Google, Yahoo, take any of the application which have service-oriented architecture where SOAP-based web services running, or your JSON-based RPC calls are running or such. So what you have is from your application, you can integrate all these different applications, maybe your banking application, trading, weather, email, blog, etc. So what we are seeing is that every morning you wake up and go to 20 different applications to browse around, 5 applications for your news, 2 applications for your emails, 3 applications for your banks or trades or such. If all these applications opened up by some APIs, then what you can do is you can write one application which will consume all these different applications from that particular application. So in the past, like if we define internet as like network of networks, then you can imagine Web 2.0 is like application of applications. So what we are seeing is like all these applications on internet is more or less like an objects. So we are seeing a distributed computing over internet, while you can write a one application using different applications from that particular application, since everyone has now published their APIs. So say for example you want to search Google today. It is not essential that you have to go to the Google site and put your search and look at your search there. What you can do is you can write a very simple program, take the Google APIs which are already published, integrate into your desktop application, write a search there, and then rest of the things will be taken care by application or APIs, and those APIs will make call to the backend. So what we are looking at is there is a great rise of mashup applications where one application using more than 5 or 6 applications at the same time. So you have a mashup from eBay and mashup from Google Maps and such. So if you look at the layers of these Web 2.0 application, what you have is a browser where Ajax, Flash, RIA, HTML, CSS, JavaScript, widgets and DOM. This is all the client layer components would get utilized. Then the important piece comes is the structures, where when you are looking at the traditional application, all traffic is usually a name pipe, name value pair. You have like you are passing foo.aspx question mark ID equal to 1 ampersand quantity equal to 5. Those kind of a traffic which either going through a query string or going through your post buffer. Now over here, this traffic, the 2.0 traffic would be going over XML or going over a JSON or going over a JS object or such. So your browser is sending these streams to the client, to the server, and server will receive back maybe XML or JSON or some other traffic. And then we have some few new set of protocols coming into picture like JSON RPC, REST, XML RPC, so. Now all these protocols are interestingly go over HTTP or HTTPS. So you don't have to open a new port for these protocols. And finally it will go to the server side where your services are running, your open APIs are running, or your SaaS is running, or software as service is running. So for example, over here, say you go to a page called pageflags.com. Now when you go to this pageflags.com and put the little Firebug plugin on, so you have a Firebug which is a little plugin comes in a Firefox where you can separate out the traffic and say show me all my XHR traffic. XHR traffic is essentially a traffic which is for a Web 2.0 traffic where your JavaScript is opening up the socket at the back end for XML HTTP request object and tunneling the HTTP traffic back and forth. So over here, if you look at what is happening is like one large JavaScript which is get it loaded on your browser, and it is making all these different calls you are looking at. Tons of different calls it is making, and all these calls are very little web services call. So all these different widgets you are seeing are like a one application running in a one large application. So multiple applications running in your browser, and all these applications are asynchronous. So you are doing something in a one part of the application, it's not going to affect other part of the application. So all these asynchronous call, it's not a synchronous call. So that is the way how this next generation or new applications are working, and new technologies are emerging, XHR or a flash based application or such. And look at this traffic. This traffic is not your traditional traffic where you see a name value pair or such. It is more like a 2.0 kind of a traffic where it is over here it is like a JSON stream, or over here it's like a more XML blocks coming back to you and such. So this is how this new applications would look like. Moving back to the presentation. So there are two important changes which we are seeing before getting into attacks and methodology. Number one is on your application infrastructure where your applications are running. You have a protocol level changes where your protocols are changed in a 1.0, or like if you look at the traditional application, you have HTTP and HTTPS only. Now you have SOAP, XML, RPC, REST, all these over HTTP and HTTPS. Then information structures. We have like a typical Web 1.0 application where name value pair is going out from the browser and HTML coming back to you. Over here, now what we are saying is we have XML, JSON, JS object, and various different customized structures which is marshalling between browser and your application. Communication method, the most interesting, like Web 1.0 applications are like a synchronous, boring, post back, refresh and redirect. Like you go to the one application, you get a 5 links, you click one, you go to next. So while your page is getting refresh and reload, you can't do anything. It's all synchronous. Your socket is blocked, your browser is stalled and such. In 2.0, what you have is like asynchronous and cross domain. So 1.0 applications used to run on a one single domain. So say for example, you are on xyz.com, your entire application is running on xyz.com. Now with a 2.0, your application is asynchronous, so you are doing something in your document object model in your browser, your application will not get stalled. So you fire an event, you keep on working on the other part of your browser and still your application is up and live. And when you say cross domain, your application is not running on a one domain, it's running on the multiple domains. So you have a single sign on, you sign on Yahoo, you go to the Flickr, Flickr will also recognize that who you are and give you the access to the resources and such. So all these applications are becoming more like a cross domain application. It's like not the binded to just one domain. And last important part is information sharing. What we are looking at is usually in a 1.0 application, you have your own database, and from that, the whole information set or information coming out. With 2.0, you have like a multiple sources of information. You are not consuming information from the one source. Say, for example, you have implemented RSS feed in your Web 2.0 application. So your RSS feed can be configured by the end user, and end user can define that I want a feed coming from CNN, I want a feed coming from Google, I want a feed coming from my banking site, etc. So pretty much now you don't have a control on the information which your end user is consuming or your application is consuming. It's all coming from the multiple source, and that is the essential need of time where people are looking for. There is an essential urge for integrated information platform, and that's what we are looking at. Now this has impact on threats which we are looking at. So we used to have a multiple entry points to the system, but all these entry points to the 1.0 application were more structured. So now if I launch my application, I know that person will come to a login page, he will pass on your username and password, and then he will go to this page, and then this page, and then this page, and then this page, and so on. Over 2.0, what you have is a back-end web services running. So this web services has like given a 36, 50, 150 functions exposed. So by sitting in my browser, I can invoke any function at any point of time. I don't have to go with one function and then a second and then a third and then fourth. So what we are looking at is entry points are scattered, they are multiple. So now you have a lot of hassle to manage all these different entry points for security reasons, which we'll see as we go. Now looking at the dependency, on a 1.0 we had a limited dependency, on 2.0 we have multiple technologies to deal with, we have many information sources to be consumed, we have many different protocols coming up, and all these is like confusion which is bringing up some of the new sort of vulnerability with the same old payload. Vulnerabilities, if you look at 1.0, we always focus on more or less on a server side, typical injections we try to do and such. With 2.0, what we are looking at or what we are adding on 1.0 is a web services payloads. We try to hack into web services, maybe a JSON web services or SOA web services. And then we are looking at the cross-site scripting and cross-site request forgery for all this 2.0 stuff. And exploitation, we used to have a server-side exploitation. Now we have a lot of different frameworks by your browsers can be exploited. So once an attacker get hold of on one of the simple cross-site scripting, your entire browser can be hijacked. He can control where you are going. He can control, or he can give you a stream by which it can redirect you to some places where he wants you to go. And a lot of stuff can be injected in iframe. So even you are not aware of where your HTTP requests are hitting, but still you are hitting from your browser. So all these are important changes which we are looking at the 2.0. And enemies, attacks, and cause complex architecture and confusion with technology. We have already seen the Web 2.0 worms and viruses, which are next generation worms and viruses, which are not infecting your boxes, they are infecting your browsers, your browser sessions, your browsers and such. So like a SAMI, Yaminer, Space Flash, all these are already popular worms and viruses which are discovered on internet for virus specific for a site and virus specific for the type of browser you are using. Ajax and JavaScript client-side attacks are on the rise. We are seeing CSS, XSS, and CSRF on it. Web services attacks and exploitation toolkits out there which can easily help in enumerating your web services and exploiting it. And importantly, Flash clients running in Adobe are vulnerable to several different attack vectors, and that is where we are seeing some of the traffic or some of the attacks hitting too. And if you want to see some of the real life cases of the Web 2.0 incidents, you can go to the webappsec.org/projects, where they have a WHID, that's the web hacking incident database, where they are capturing all the incidents happened in the year. And already we have seen Gmail CSRF exploit and hijack a domain. We have seen Orkut XSS making money, MySpace, which is essentially from blogs and boards. We have another XSS with a RSS feed. We have a MySpace where Flash component was exploited. We have HTTP response splitting for Google bloggers and such. So all these are different kind of 2.0 attacks which we're already seeing going in live World Wide Web. Now, how to discover vulnerability? If you are coming across a Web 2.0 application, how you can discover these vulnerabilities with your 2.0 applications? So we are focusing on different methodologies, like a black box methodology where you try to run a script or you try to run a tool and try to identify vulnerability. And then you have a white box where you have a source code with you, analyze the source code and exactly pinpoint a vulnerability. So 3 important steps before performing an attack or performing a vulnerability assessment you need to do is, one is a fingerprinting, second is the discovery, and finally enumeration and crawling. Fingerprinting is application framework. What we are looking at over here is like more or we want to know which web server they are running with, and on top of it, what web application server they are running with. And then we can do a discovery, go for the crawling 2.0, and then we do a scan strategies for fuzz or a scan the application, and then come up with a secure coding or a firewall. So when you do a fingerprinting, what you are looking at over here is what kind of a back-end application server you are running with, because that gives you an inclination that what kind of a Web 2.0 technologies they are using. Say for example, they are using at the back end of WebLogic or a Tomcat or Atlas or Dojo, what they are using or what they are running with, what kind of a structures they are running with. So that's the whole objective of doing a fingerprinting. So over here, for example, this is a very simple tool which you can download from our site, like AppPrint. What I'm doing over here is you just pass on the IP address and just do a scan. Over here, what it's going to do is, number one is definitely go and try to identify which web server you are running with. But that's very common. You get it from a banner, or over here we are sending 12 requests and identifying the behavior of the banner. What I'm more interested is in the backend application server. So when I get the HTTP banner back, I'm not going to get what backend application you are running with. So what I'm doing over here is we are sending 2 or 3 requests by which we try to invoke various different backend components. Whether you are running with a WebLogic, you are running with a servlets, you are running with a JSP, you are running with ASMX framework, which is calling a .NET framework or such. So over here, I'm trying to fingerprint. Are you running with Resin? Are you running with a Tomcat? Are you running with WebLogic, WebSphere, Orion? Which application framework you are running with? Once I have this information in place, I know what kind of attacks I can perform or what kind of attack an attacker can do. For example, if it is a Tomcat, then the web services engine is Axis. If it is a .NET, then web services engine is ASMX and such. So this is the one part where I'm doing a fingerprinting of your of the web application framework or web application infrastructure. Once I'm done with that, next thing I'm interested in is what kind of a AJAX call you are making, because that is where the most important or critical point line. That you are using HTML, CSS, it will go to the JS DOM, it will go to the XML or XML HTTP request, XHR object, and then you make an asynchronous call over HTTPS, will hit to your web server, go to the XML pipe and data source. So there are various different libraries out there which are using different libraries like Dojo, or you have a toolkit from GWT from Google on such. And all these different toolkits have their own different vulnerabilities, like JSON hijacking or doing a CSRF with libraries and such. So what I'm interested in is identifying those backend pieces or backend library or fingerprinting them. So over here, what I'm doing is I'm very quickly running a simple Firebug over here and try to see what kind of a call going at the back end. So over here I can see those calls and then I can analyze their source, and over source I can identify this is using XHR, or over here this is using a protocol or a prototype library over here. That is all manual. Or what you can do is you can run a simple toolkit called scan web 2.0. Over here I am trying to identify all these different sites, what kind of a technology they are using with. So I have collected fingerprints for various different toolkits over here, and I just write this bat file which will kick on 3 different servers. So first I'm looking at is on this my demo site where it is clearly, these are the list of toolkits, popular toolkits like Prototype, Scriptaculous, Dojo, DWR, MoveFX, jQuery, Atlas, etc. So over here on the first I've identified that this guy is running with a prototype.js. Then this guy, it is running with a combination of a dojo.js and a jQuery.js. And then on Apple, I can identify that it is running with a prototype.js and a scriptaculous.js. Now, this will start adding into my information pool that particular application running with this web server at the back end, this is the application server. On top, I have these kind of a toolkits or these kind of a tools or a development framework which Target is using. Then you can go ahead and discover the publicly known vulnerabilities and try to analyze them, that how strong their security measures are and such. Next, what you can do is you can do a flash-based scanning as well. So say for example, your application is running with a flash. So I want to do a flash fingerprinting. There is a flash finger.rb. So what I'm doing over here is just I'm trying to scan the app pages and try to identify what kind of SWF file they are running with. So over here very simply I've identified it's running with a finder.swf. The next is there is another piece where you can identify what kind of a framework it is running with. There are 2 popular frameworks out there for if you are loading your Flash or a Flash-based application. One is from Adobe, which is a Flash 2 or Flash 3, whichever framework you are running with. And then there is an open source framework called Leslo. Now this, if your developer has written an application using a Leslo, then Leslo has a LZX file, that's the decompilable files. So you have these LZX files over here in a second part where you can identify these LZX files, you can download them, you can decompile it, and you can see the full business logic from that file. So you're starting to gather all this different information about your target application as such for the application which you want to assess. Once you are done with that, then what you are moving on is that I want to do a discovery. That essentially when I do a discovery, I'm looking for that what kind of a structures I have to deal with. Whether I am doing a JSON, I am doing a JSON array, I am doing a JS object, what kind of a structures which is marshalling between my application. So that is a very important piece, because then when you do assessment, you have to inject your payloads into that. It's like, say for example, you do see a name value pair traffic, then you have to do a name value injection. If you do a JSON, you have to do a JSON injection and such. So in the next step, what I'm trying to do over here is just do a framework. So just say for example, I'm doing this login.trade.aspx page. I enter my username and password over here, and user is authenticated. Now I can run this script called scanatlas.rb, and over here with this I can identify it is running with the backend trade.asmx page. So I know that there is a backend web services running, and this is the traffic which is going to look like. Now over here, this traffic is coming back as a very simple customized structure which is coming back. There is no refresh and reload. Just when you click a button, this is the traffic what it is going out, and this is a response which you get back. So it is entire DOM is not getting reloaded. It's just the full bits and pieces of a DOM is getting reloaded over here. So I've identified that over here in this application, it is running the backend structure, running with the Atlas. You have a backend web services running with the ASMX, and the front end is your JavaScript. And then there are various different structures which you have to deal with, like a JSON, XML, script, JS array, JS object. Very quickly, I can show you a few of them. So when you click this page, you get these kind of a response back. Now you can see this response is not your traditional name value pair or HTML response. It is called JavaScript object notation or a JSON over here. Or for example, if you click this guy over here, say XML, then you are getting the XML stream back over here. And all these is, as you can see, it is coming on the AJAX traffic. It's coming over XHR over here. So the second part where I finish my discovery phase, where I know that what kind of a traffic I would deal with when I do my assessment on the application. Now, interesting part. Now, how do you crawl these applications? Say, for example, you are dealing with a 2.0 application. How you go ahead and crawl the entire application as such? That is very interesting crawling and enumeration for the Web 2.0 application, which essentially dynamic page creation through JavaScript, and you have a DOM event management from the application layer and DOM having the clear context. So if you try to crawl these applications using your protocol driver, you open a socket, you send a GET request, you get a page, you have a href, you pass all href and keep on bundling this request, and then you make a complete crawling on the site, which will not work over here, because to crawl the site, what you need is two important things. One, you need a JavaScript execution capability, and even you have a JavaScript execution capability, you need a context of that particular DOM. So if you have both of them together, then you can fire the right event to crawl the application. So over here, for example, if you go ahead, and this is a typical dynamic site for a sample. So what you have is, when you load this site, it will load 4 hyperlinks on the site. Now all these hyperlinks are not part of your HTML page. It is coming as your AJAX call. So if you look at the source of the page over here, the source of page is like a 4-line of scripts, which is getting loaded in your browser. There is no href you can see in this HTML page. So you are like, if you start crawling this application, you are like, at the first page your crawler will stop, because there is no href, there is no form button, there is nothing is on it essentially. It's all in the JavaScript, which get executed dynamically once it gets loaded on your DOM. So then you start crawling this application once you start clicking all these different buttons over here, say news or whatever button you click, everything is going over AJAX call. So essentially what we are looking at over here is like a one-page application. It's like nothing else on this particular page. It's like a one-page application. So say for example, interestingly, if you visit msnsearch.com, msnsearch.com is like a one-page application where there is a backend web services running with 132 functions. So like, what do you crawl? Like you go make a request to a / and your crawler will end, because there is nothing else in the application. So say for example, you start crawling these kind of application with the Paros. This Paros is like one of the scanner which you are using in crawling. And over here you start a crawling, and it will stop very soon that nothing is found. There is no link. When we load this particular page in your browser, you can see so many links. You can click events, you can do a lot of stuff. Over here you pretty much don't see anything. So your crawling is finished over here. Now what you need to do is, over here what I do is, I do a whatever. So whatever is a type of a driver which you load it from the Ruby script. So you write your Ruby script, tell your IE to load this page, and then dynamically click with various different links. So if you are doing that, then you are actually doing something which a human is doing. So you can write the script, run against your Web 2.0 application, go home and sleep, and in the morning when you come, you have the complete traffic with you. You run the pattern on the traffic and capture all the links and the resources from the site. So over here, what I'm doing is I'm just saying IE to go to my target application, and then slip for a 1 and start clicking all these different events, or all these different events or links which I find on the site. So very quickly I can crawl the application. As you can see, everything is happening automatically over here, and then I'm collecting all the hrefs through the script. So all these hrefs is getting collected, and now I have a full profile of this particular application, that this is the application running with this web server, running with this application framework, it is running with this JavaScript library, it is using JSON and XML on these particular resources, and blah, 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 blah. So you have a full list with you. So this is one approach by you can crawl the application. And second is, you can do in-browsing crawling. There are various different plugins out there. For example, Chicken Food is one of the plugins which you plug into your Firefox and write a little script in a JavaScript and tell your plugin that I'm loading whatever is loaded in my current DOM. You parse that, collect any link which is starting with a JavaScript, so you know that that href is pointing to a JavaScript in your DOM. And then if it is pointing or starting with a JavaScript, you click that particular link. Very simple, like a human or like a way we are thinking. So then you can see all these different events are already fired. You it made all the 5 links which is clicked by itself. And then you have a traffic over here which you can analyze and determine what's going on. So this is the way essentially what you are doing is identifying your different attack vectors. Now we move to attack vectors. Once you are done with that, now we are looking at the top 10 attack vectors. First is Ajax-driven cross-site scripting, second is a JavaScript, and so on. So first is Ajax-driven cross-site scripting. What is different in Ajax-driven cross-site scripting? First is Ajax call get a stream. So when you make an Ajax call, you get a stream back from your server. Now, when your already DOM is preloaded and new stream coming from the server, what you need to do is this stream has to be injected into your current DOM. So there is some kind of a call which will take this new stream and inject into a current memory space. So it uses either a call called eval. So whatever is coming, it's do a eval. It's like doing a command execution on your browser's DOM and through a JavaScript. Or you need to do a rewriting, whether you do a document.write or you change the inner HTML or such. So one of the fundamental thing over here is that the stream which is coming to your browser is coming from the untrusted source if you are running in the mashup application, and cross-domain calls are very common So you have a cross-domain calls are one of the important ingredient of your Web 2.0 application, and to bypass a cross-domain or a same origin policy in your browser, developers have done 3 ways. One is it will talk with, those calls will go through the proxy. So say for example, I am on xyz.com, I can't go to the google.com. So what I will do is on the xyz.com, I will create a proxy and my application will call the proxy and tell the proxy that go to the google.com and this is a gentleman's username and password, go and grab their email and tunnel it back to me. So that's the number 1 proxy. Then there is something called callback implementation, which is if your APIs are supporting that, then you can wrap around your callback function and make sure that when stream comes back, you process into that particular function. And then if you are using a Flash application, then you have a cross-domain XML where you can code it up and say that if my application is trying to call these 3 domains, just count it as a trusted and let the traffic go. So this is how your cross-domain calls are going to get bypassed. Now, how a scenario of injection on the 2.0 application is going to happen is an attacker will write something on the blog. That blog will get converted into a kind of a JSON feed, and that will go and waiting for on the proxy. So when your web client or you get connected through the application and looking for that particular blog values, that you are not going to that blog, but the stream which is written is coming to you. So then that JSON field will tunnel through a proxy, will go to the web server, come to the web client, and then it will process your JSON, it will do the eval. As soon as it will do the eval, if your stream is not validated, if it has a malicious code inside, then that is going to cause a cross-site scripting on your site, on your browser. Now this is like a third kind of cross-site scripting, which is a document object model or DOM-based cross-site scripting. And this can be very lethal. This cross-site scripting with RAA, it's possible if you are using a rich data application, then it's going to go through that. And these are the functions by which these can happen, document.write, or it can go over a JSON, or it can go over a JS array or such. Just the same kind of a mechanism can be leveraged in terms of a second attack vector, which is a JavaScript injection and mashup. So mashup applications are combinations of different APIs, and you have a source of information coming from untrusted, and when these callbacks are getting executed in your browser will cause a cross-site scripting. So say for example over here, I have where it is. Over here I have this application running where there is a mashup. So this is a typical mashup of your Google and eBay. So like on this particular site, whatever DVDs are posted on by someone on this particular zip, show me that. So then these are some of the products are posted. Now You are running with the JavaScript where it is communicating with these two different domains, bringing everything onto it and running on your site. Now you are looking for these guys' profile. You go there and click this guy, and you can see over here what he has posted and who he is and such. Now if you start analyzing the traffic over here, as soon as you click this, you have when you click this, it is sending you a XML stream, his first name, last name, and a number, and that is going to get executed in your browser. So essentially over here, when you say, for example, I click this guy over here and do a view page source over here, this is how the XHR call will go out, grab that information, and over here you can see it is doing a document.write calls over here. So this is the way how it is going to execute the new incoming stream, which is coming from the untrusted source. Now, if that particular profile, if I click over here, it is a cross-site scripting 2.0. What have happened is this guy has injected a malicious JavaScript in his last name. Now your application is going out through the proxy, grabbing the information from completely untrusted source, taking that and making the eval and document.write on your domain. So now with this, whoever is visiting these guys' profile is going to get XSS. So this is like a different kind of a 2.0 kind of XSS, which is a DOM driven, number one, and number two, it is coming from the untrusted sources. So this is A2. Number three is like SQL injection over 2.0 type. This is another interesting vector. In a traditional SQL injection, what you have over here is a get and post, where you have inject a value over here and you get the response back, and from which you identify whether it is running with the bug or not. Now 2.0 traffic would be going over a JSON or XML. So say for example over here, I have a typical, say, this is my typical 1.0 resource, where you have a page and you have ID equal to 1, where you put ID and you get a product information out. So if you put 2, you get a second information and such. And as soon as you see this, the traditionally way you put a single quote and try to see how application is holding up, and you get SQL error and blah, blah, blah. And you have now know that this is a 1 or SQL injection point you have found. But if it is a 2.0 application, this is your application. Your catalog would look like this. There is no ID over here on a top. And if you click this link, your things are dynamically changing over here. If you want to see this product, it is changing over here and so forth. So now you don't have that ID parameter over here or a name value pair where you can change. So now you say, for example, you do a traffic analysis over here with the paros, say for example, and try to see what's going back and forth. Do a new session over here and trap the request. As soon as I click this guy, this is the traffic which is going. This is little JSON traffic which is going, and you have a product 2 information going over here. So say instead of a 2, you put A and continue. You get the response back, and here is your response. You can see SQL exception error coming over here, but in a browser you don't see anything. So it's not like the typical 500O, or it's not typical 200 which you are looking at. So you need to do this dissecting of the information and try to identify where the errors are coming. Now this is an error coming from the framework which is running the JSON objects. So now you have the SQL injection point found. So now you go ahead and click this guy and identify this request, and over here you already have a trap place. So you encapsulate with this, say, double quotes, put 1 or 1 equal to 1 and continue. And in a response for this second product, you can see the whole product table coming out. Instead of getting a one product, now you're starting to see all the products, and your SQL injection vectors will start working on JSON pipe. So this is kind of a new kind of a SQL injection. It is not a new kind of, but like a Payload is the same, but your delivery mechanism is different, which you need to analyze. 3 is a cross-site request forgery. Generic CSRF with a get and post. You have IMG script and iframe tags through which you implement your that. Now, IMG script and various other tags don't have to follow same origin policy. So what you have is a cross-site request forgery for Web 2.0 traffic. So say for example, you are using XML traffic for marshalling your request back and forth on 2.0. So what you are doing in this scenario is you are from a laptop, you are logging on to your trading application, passing on the login request, and you get authenticated and you get a cookie back from the server. Next, what you are doing is since this is a 2.0 kind of application, you are sending an XML request. You are sending an XML request for buy, that I want to buy 20 stocks of Microsoft. So since you have already authenticated, you have a cookie in your place, that request will go and application will identify who you are and place an order for you, and you have a buy request is placed now. Now, what you are doing is you are still on, your session is live on that, and you are going to attacker site where you are browsing around and you get a CSRF page load coming to your site on your browser. That will, without your knowledge or without your intention or inclination, that will force a browser to send XML string. This is not a typical name value pair. It is XML string which will get injected into application, and application on behalf of you, 25 stocks of a Google has been placed now. You have no idea what have happened, and all over 2.0 and XML string. So over here is the payload. Over here what we have is a form. You have a hidden field. Now what we have done over here is a name value pair. In a name I have injected one half of a XML block, which is less than $XML version, and the rest of the part of my envelope which I have placed in a 1.0 into the value. Now, and then I have a document.by submit button. So as soon as this page get loaded in my browser without any knowledge of this particular guy or without any click from this guy, what is going to happen is this particular form will get executed and a legitimate XML envelope will be created. And as a post request construct an XML, construct any HTTP request, what it's going to do is it will take a name, it will take a value and put equal to in between. So as soon as it put equal to in between, the XML document will look like less than $XML version equal to, that's coming from the post 1.0, and then that's a full legitimate XML envelope which is going back and forth. So this is like a JSON, or this is like a XML called a one-way CSRF. So over here, let me quickly show you the demo for this. You have, okay, over here this is a page. You are on a mytrade.com, and John is logging into the application. His user is authenticated and everything looks good at this point to John. He go ahead and place an order now for Microsoft 25, place a buy order over here. And what you have is, this is a response which you get, which is XML over here, which is saying order is placed, and that same response you can see over here as well. And if you look at the request, again this is XML request. This is not like a name value pair where John has placed like a quantity equal to 25, ampersand type equal to MSFT or such. And then everything looks fine and his order has been placed. Now he is going to a site called mytrade2.com. This is not the same domain. This is a different domain where he is now. And just to show, I placed this visit link. It's not required. It can just dynamically load it on the same page and this attack vector will work. So as soon as he clicks this link, you can see one request generated over here. Now this request is going to mytrade.com where he's already logged in, and he has the XML envelope as you can see over here. XML version equal to 1.0. So without his knowledge, this order has been placed for 20 value of Google stocks, and he has no idea about it. So this is essentially a CSRF, cross-site request forgery, one way where you are just forcing the browser to go out. Now there is a mutation to it as well. Say for example you are using the JSON instead of XML, or a JS object or a JS array. Then what attacker can do is it can open a two-way channel. So over here now what we have is browser will, as soon as you go to this attacker site, it will load the payload into your site, and that will go out force a request from your browser to go to a target site, fetch the request, fetch the response in a JS array or a JS object, and whatever value you have will send back to your mothership or where your listener is running with. So over here, say for example, your banking application is giving a profile.aspx in a JS array. So this is a JavaScript array where your profile is coming to your browser. So over here, what I can do or someone can do is doing a function overloading of array. So as soon as I have my page where it is not using the function of the array of your browser, but it is using your my function, which is already a part of the array, so it's get overloaded. And as soon as your array come to me, this function is going to be get loaded, and all your value from the array will get stolen and sent to the target site. So over here, say for example, we go to this quickly a demo. I don't have much time now. But over here, this is what I'm getting back when I do a profile.aspx. So now as soon as I go to the mytrade2.com, you can see what have happened is 4 requests which are generated, all the account value, John Smith and such, and sent back to mytrade2.com. Over here is a collect.aspx page. Here is my array overload, and here is a script src tag which will not follow the SOP and force your browser to send a request to a target page. So this is another new vector or kind of a new vector which will run against just the JSON or a JS array or object. Then you have RSS manipulation. Your script, you are getting a RSS feed coming from your various different untrusted sources. So if your RSS application is vulnerable on 2.0 application, so here I have some widgets where different widgets are there for a calendar and weather and such, and then there is a little RSS feed widget. So you click the trade news. So over here, as you can see, the request is going for proxy.aspx and then going to RSS news. You continue that, and here is what response you get. Now this response is XML response, which is RSS feed, a legitimate RSS feed which is coming to your browser, and application is just loading it without validating. And as soon as you click this, it's the cross-site scripting, and someone has injected a script in your feed over here. Here is your link. So any payload, any iframe, anything can be injected over here. It is a very simple alert which we are injecting, but anything can be injected over here. So this is another vector which is RSS manipulation. Then you have RSS feed. Another is a reverse engineering and logical hacks. What you can do is essentially you can download the full Flash component. You can download all the JavaScript and reverse engineer. There is a debugger out there which you can use to debug JavaScript and try to reverse engineer the logic. Now, with a 1.0 and a 2.0, the cardinal difference is that a lot of business logic has shifted to a client side. So in previous components, all these business logic used to run on the server. Now you can see this business logic bits and pieces in your client side. So 2 or 3 applications where we have analyzed where access control was little part of this script, where you can manipulate values and try to hack into the system and try to bypass authorization on the logical hacks. And finally, you can do a WSDL enumeration and exposure. WSDL is essentially what you are looking at is your web services definition language, where if you are running with the web services at the end, then there is a WSDL, and if it's opening a function which are not a private, which you don't want to expose, then you can have an attacker can enumerate this WSDL file and identify possible hacks. So say for example over here, you are running with the enumeration with the WSDL. So here is your page where you have access point where you have a full WSDL file, and what you can do is you can download this WS scanner, point your web services to WS scanner, and you can see all the functions over here. Now what we have seen is like many times developers, when you analyze these functions, you can identify certain functions which are admin function, certain function which if you brute force these functions, you can get the internal privileges of the application. So then you can go ahead and start the listener over here on the port, and this is the SOAP traffic which is going. And you start playing around with all these different fields like we used to do with the name value pair, and try to see what you are getting out from the application or assessment of this particular application. And then if you want to do further assessment, you can do SQL injection over here on the SOAP envelopes. So all these different soap envelope where you can do the injections over here. So you can do 1 or 1 equal to 1 over soap and such. So this is what can happen. This is all over a soap injection. You can do a fuzzing if you want to do a fuzz of the soap request. WS scanner has something called WS fuzzer. So what you do, you define target, you define a fuzz load, you define your regular expression, what you're looking at, and then over here I'm looking for a 500 and fault code, because fault code is like a 500 error for your application. So when a soap fails, it gives you a fault code instead of a typical message. So I'm looking for all this and this, and then I start fuzzing. So I write a hash fuzz hash where I want to do a fuzzing, and I leave it and start the fuzzer, and I can start enumerating all these errors. You can see these red stuff, where all these errors are the fault code which are possible to exploit further. Now I've identified the points which are vulnerable in your SOA or a SOAP or a service oriented architecture and such. So all this is essentially next attack vector, which is a SOAP and other service injection which you are doing. Once you have a web services, you start doing injection into it. Identify or discover injection point, and everything else is the same. Whatever you are doing for your traditional application, SQL injection, LDAP, XPath, whatever you are doing after that is the same. And finally, the widgets and gadgets hacking. Few of the gadgets and widgets frameworks which we have evaluated in the past. What we have seen is like when your gadgets and widgets are running on the same DOM, then one of the gadgets, if you have a JavaScript for that gadget, that little gadget can actually monitor your entire DOM. So then if you have a Gmail gadget over here and your malicious gadget sitting over here, and you enter your username and password in that Gmail gadget, this gadget can see what you are doing on the part of the DOM. This happens when you are using the same DOM. So what we are seeing is like, say for example, if you go to the Google or IG page or such, what they are doing is every gadget will get loaded in their separate iframes. So then where they are separate, running on the separate iframe, what is going to happen is that iframe's DOM will be restricted to that particular DOM only. You won't be able to access DOM from the same DOM. So that's different kind of when we are looking at the widgets, gadgets and module architecture, these are some of the checks which we make and try to identify what kind of a vulnerability can be running on this. And then finally, for the countermeasures and security, scanning the code base, identifying linkages, method signature, all these different things which you need to do for the 2.0 perspective now. And in 2.0 application, it is if you have the source code, it's a probability of identifying vulnerability is high compared to a black box testing, because a lot of things are hidden and hidden calls are going on. And second, you need to do a content filtering. If you are using the application layer firewall, it's a name value pair firewall will not work. You need to do a SOAP or a JSON based traffic analysis and ISAP level filtering to identify XML blocks and XML tags and such. So this is all about the content filtering and such. So these are the top 10 attack vectors which we are seeing popular. Once you have vulnerability, then there is a whole range of exploitation which you can do a one-way attack, or you can upload files and whatnot. Several things which you can do, and all these will happen over a JSON pipe or XML pipe or such, like used to happen on a traditional way. So in conclusion, Web 2.0 bringing new challenges for the folks who are doing assessment and audits. It is also challenging for who are developing the application. It's to adopt new methodologies for scanning. Attacks and entry points are scattered and multiple. HX and SOA are key components which we are seeing. WEF and a code review are important aspect for Web 2.0 defense, like a traditional defense. So that's pretty much what I wanted to cover. Any questions on this? I have some time for questions. Yeah, like 1 or 2 minutes. So like, any question? A question? Yeah, please.
I didn't quite understand with the XSRF attack with the XML envelope.
Okay, I can very quickly show you.
Yeah, the same domain policy. I didn't quite understand why that didn't kick in.
What I'm doing over here is, it's an interesting question. when I was looking at one of the clients where I'm working was, they were using this XML envelope back and forth for the analysis. So I wanted to do XML based CSRF. So I want to get a typical HTML form loaded, which will initiate an XML request to my target application, right? So definitely you can put a SRC tag and put if it is a name value pair, it's a very common. You just put ID equal to 1. Now how you can do the same thing with XML? So you have to have a post request, and in your post request you need a legitimate XML envelope going. So like how you can do that? That was the challenge which I was facing with. So what I did over here is I created a form. In the form I put in input type hidden, so that's like it's not going to be visible, and I have dissected that envelope wherever there is equal to first equal to sign. So that first equal to sign is going to be injected by my form, which is like a typical form. When you push a button, what it's going to do is it is going to take a name, it is going to take a value, craft a post buffer and put equal to in between, right? So what I've done over here is in a name, it's not the typical name like ID. In that, what I've done is I've injected a part of XML. Less than question mark XML version is a part of my name, and rest of the envelope without equal to sign is part of my value. So when this particular script get automatically generated the submit button, it's going to put equal to in between, and my envelope will look like a legitimate XML envelope. The only trick over here is that when you do this way, your post request content type will be text HTML, and when you do with the Ajax, your content type will be XML/application. But a lot of these frameworks are not checking that. So they are not making sure that whether it's coming from the XML HTTP request call or it is coming from the form. So if they are not checking that, then this particular envelope will go through and whatever is going to happen is going to happen. So like I've evaluated 3 or 4 different APIs using in Java and ASMX framework. All these are not checking that. So that's the way how one-way CSRF would work with our 2.0 streams. Any other question? Very interesting question. Okay, so pretty much I'm done over here. Here is my email address, and you can reach me at shreeraj@blueinfy.com. And whatever tools which we have discussed are part of the tools.html, which you can download from blueinfy.com. And thank you very much for listening.